almost finished the semester. We have 2 more lectures. So today we're going to talk about immunology. Hopefully we finish it, then we'll talk about the virus, the last one. I don't want to talk about virus at the beginning because you heard about too much, the 2 years. And we will talk about virus, then we will put the final exam review question on the eCampus over the weekend. Then you can go ahead to study. And we will go over next Tuesday, when we finish talking about virus. And the next week, Thursday, same room here will be the first early exam. Okay, then Friday afternoon, 12:30 to 3, in the lab room will be a second early exam. Then will be the university scheduled exam, will be December 16th, early in the morning, like 8 o'clock to 10. So that's the only 3 spots we offer. I'll send the email again. Try to do those 3 spots and don't do other time. I don't have time because if everybody coming individually, then we will never gonna finish it. Okay, that's why the reason I never returned all the exam paper, because we haven't people haven't taken exam 2, exam 3, lab exam yet. So just want to let you know, I used to return all the exams to everyone. Okay, so just want to let you know. All you lab grades, including attendance points, I already imported them, and lab notebook check, and also the final exam of lab, you could be accessed to eCampus, I think no later than next week, Monday. So you get to know how much you need. But I would recommend you study as normal. Some of you are very good. You only need 60 points to get an A. Don't study only that 60 points. You keep the same pace. Some of you may not do very well, but don't give up. I always say that we all have at least 140 points. 100 points for the final lecture exam. 10 points will be the extra points we do all the time. Don't forget the 30 points is bonus for the essay writing. But remember, you have to write in the classroom. Okay, I'll send the email again. So 140 points to up in the air for grab. So don't give up. If you cannot get a B, at least you cannot get an A. Sometimes you can get a B. Sometimes you can get a C plus or the B minus sometimes. It's not too bad, I'm serious. You get a B minus, some people doesn't do very well. I mean, some people should find me in the parking lots last year, the year before, they said, the only thing I get a B minus is in your class because you gave me a little bit bonus. So I said, okay, that's not too bad. I mean, okay, so that's just want to encourage you to keep studying. It's all the same. It's the same pace, same level. It's not going to be too difficult. Okay, we're going to talk about immunology. This is related to what's current situation a little bit, so we want to think it's important. First of all, we had a natural defense system in our body, which is the bacteria. Our intestinal area, there is millions, thousands, millions, or billions of bacteria. There are 10 times as many as our human cells, and they are our natural immune system. And there is most research saying they are maybe even as important as our brain and our heart system. Lots of research they do that. So we keep talking about those. But I just want to let you know, our normal bacteria in our body pay much attention for the host microbial interactions, which is a natural immune system. Now, we do have some of the defense system in our body. The idea is we're going to repel the foreign. So the foreign could be a bacteria, but sometimes it's a good thing. For example, some people do the organ transplants. They're not really successful in a couple of years because they treat these organ plants also as a foreign. So your immune system will also react for that. Sometimes you have an allergy. Remember, all the allergy is an over response for the immune. So does not mean everything is good for the immune. Sometimes do give you some side effects. So what we're going to talk is surface defense, phagocytosis, which means related to lysozyme, and real immunity. Now, what are the bacteria going to do? The bacteria will be doing to establish infection, to resistant host defense. They're going to do some invasive, or they're going to have to damage the host. That's what they do all the time. Okay, this is the important slides I would love to tell you. These days, you see the news all the time. I'm not sure you look at the other news. Some people will say, I have a salmon sample. I have a package coming from Amazon, which is tested coronavirus positive on the surface. If that means you're going to get coronavirus, maybe, maybe not. Because this is the concept here is colonization versus infection. So I want to mention this in this class. You had a coronavirus or bacteria tested on a packaging machine, on a packaging. You have a coronavirus tested on the salmon, on seafoods. Does not mean it's going to transfer to you. It really depends on your immune system and how it's be there. Because colonization, which means it's only attached, especially like a virus, it's an obligate surrogate. It's an obligate parasite. Obligate parasite. They need a host. So colonization does not mean it's going to cause infections. When they cause infections, they need to go through the whole immune system. They had to attacking and crossing all these immune systems. So some of the news will make it a big deal to say, oh, there is a packaging that has a coronavirus. Oh, you shouldn't do this, you shouldn't do that, you shouldn't eat seafood. It's all, when you learn in the class, you should all know. They are confusing you about these two concepts. Okay, so what is colonization? That's very easy. The bacteria go into your body. Now that could be eliminated immediately if you have a very strong immune system. That's called transit. Now they go into your body. They could cause infection. But does not really mean infection causes you disease. Not really. Sometimes it could be a bacteria become part of your normal bacterial system. Now, of course, it will cause disease. If it's the microvirus has been passing through the immune system, then cause infectious disease, of course. This is most time we will be happening. Now, also it could be asymptom, which means you have a strong immune system. You did not show any of the symptoms there. Last one. It could be the bacteria, although they infected in your body, it's be there the rest of your life, but never cause problem. Sometimes even you recovered, it's still there. Let's say hepatitis virus. This guy, sometimes people has liver disease, infections with hepatitis, even recovered. You do the testing, routine testing every year, you still find the virus there. That's, we call, it's a carrier status. No apparent symptoms, but the microbe is shed. That could become a chronic, okay? So I just want to tell you one thing. These two are important concepts. Even infection could have these four different types of the results. It all depending on your immune system. Now, this is the host resistance overview. So most of the pathogens, they will overcome surface bacteria, surface barriers, rich underlying, and they all come resisted by host. Now, including we have a non-specific resistance and specific immune response. So here we're going to talk about some of the terminology. And you can go back to look at these. It's so easy, it's just written there. What's the immune system? Composed by tissue, organ, cells. They recognize foreigner to neutralize, destroy them. What is immunity? Ability to resist a particular disease or infection. What is immunology? Science behind that. Now the immune, we have a non-specific, specific immune. Basically, is we got to react to the foreigner. Then the body is to resistant to that. Some of them will generate antibody. Some of them do not generate antibody. They have a shorter memorization system. Some of them have a longer memorization. These are all overview talk. Here is the slides, which is give you something more detail. So we have basically two different systems, which is non-specific immune system, which means it's a universal defense system in your body. So I'll give you some examples. The skin. We know the bacteria. Some of the bacteria will not survive on the skin. Some of the bacteria will survive. Let's say Staphylococcus aureus. Why? Because the skin, if you're running 100 meters, you're going to sweat on it. Is that right? What's going to come out? Is salt. This is a natural antimicrobial to killing bacteria. But some of the bacteria, if they like salts, they will survive. Let's say Staphylococcus aureus. That's why Staphylococcus aureus and also Staphylococcus epidermis, they could still survive there because they like those salt environments. We call it halophiles, if you still remember the terminology. But most of the other bacteria, they cannot survive even with around 2% salt. So the skin is a defense system. Second one, if the bacteria into your mouth, what's the first thing? Salivation. It will be generating lysozyme. And the lysozyme we will mention later on. This will be curing bacteria. Then they're going to go into your body. Go to the stomach. Okay. What's the stomach they're going to have? Stomach acid. The stomach acid is very low pH. pH is only 1 to 2. Lots of the bacteria could be killed. Okay, then they go what? Go to the urine urethra. Become a urine sample. And then when you urine, you do the flushing, taking out of the urine. It is protected by yourself. So that's why we say never hold on to pee. In the urine sample, you have urea, remember? You have lots of acid. You have bile salts. And all these will curing bacteria. Now this is really good for the female, or for the male, because the male's urinary tract is very long, it's 20 centimeters. And the female is only 5 centimeters. That's why female is always a risk for urinary tract infection. And what is the number one pathogen? Did you do good in the exam? It's E. coli. It's very easy. So now go here specific for female in the vagina tract. We have a lactic acid bacteria there. The vagina tract, the pH is always low. It's about like 3 to 4 because lactic acid bacteria there will be protect you. Otherwise, some of the yeast or pathogenic modes could be there. Let's say Candida albicans could attack you. So, and don't forget the last one, is all the bacteria in intestine. Now, for other things, when we mention about the lysozyme, don't forget your cherry. That's called conjunctivitis from your eyes. So there's a joke they always say, the girl has a longer life than boys because they're always crying. And when you're crying, you come out with lysozyme. Is that right? The lysozyme will also kill bacteria. So these we listed here, same as here, which is talk about is the surface defense system. Now, of course, coughing, taking out the bacteria, the mucus coming from the alveolar area, which is entrapped bacteria, let them take it out. Finally, become a sputum sample. That's also protection by yourself. The flushing we mentioned about that. The low pH lysozyme bile we all talk about. So that's surface defense system. Now, when we have these here, don't forget.
FanDuel Sportsbook, you can make every tip off.
Can you stop that second? Don't forget the white blood cell. That's another system. And the white blood cell has an important thing called the macrophage. This macrophage is a good thing. So, let's say in a bacteria going to your body, it's an E. coli. What happens is, it will be usually engulfed by a macrophage. And once they engulf the macrophage, this becomes a phagosome. Phagosome. This phagosome will release lysozyme there. Once the lysozyme there, they will be killing bacteria. Now, how the lysozyme kill bacteria? Do you still remember what is NAG? What is NAM? This is, you're gonna go back to see the exam 1. Don't forget. N, acetyl, glucocyanine. What is NAM? N, acetyl, muramic acids. How they connected with each other? It is a beta-1 for glycosidic bonds. And what's the lysozyme they do? The lysozyme will cut that. Why NAG is NAM is important? They are composed by peptidoglycan. What is a peptidoglycan important? For the bacterial cell wall. So these are the things we need to important. If you go back to the exam 1, then you understand the lysozyme, how they work. Okay? So that's a macrophage. Okay, then later on what we're going to talk. Humoral immune and cell-mediated immune. We will get in there. This is another slide. What I coming from another textbook, which is to give you an overview. Again, so conjunctival lysozyme flushing action of tears, I just mentioned. Respiratory mucus, cilia, normal intestinal bacteria, flushing urine sample. We had oral mucus, and we have alimentary mucus, stomach acids enzyme in the skin, fatty acids, normal flora, and the lysozyme. Okay, that's a non-specific surface defense system. Look at your body. How many normal bacteria there? Millions of them. Look at here, this is SPP, which means it's a species. That means there is a tremendous amount of belonging the genome. Remember, nasal area, Staphylococcus, Haemophilus influenza, Streptococcus, Corynebacteria. Those are your normal ones. Some of you send me the report. You find the Corynebacteria, some of you, is that right? Nasal area. Now, if they translocated, they'll cause problems. That's why we call it an opportunistic pathogen. In your mouse, we did a throat culture, remember? I said, make sure you're in the tonsil. Don't touch other area. If you touch other area, what you have? At least 5 major other species, Streptococcus, Fusobacteria, Acidomyces, Leptotrichia, and Venezuela. I didn't even know the other 2. Skin surface, what you have? Bacillus, Micrococcus, Staphylococcus. Vagina area, number 1, Lactobacillus, Streptococcus, Corynebacteria, Candida albicans. Candida albicans sometimes is a pathogenic one. Urethral tract, bacterial rods. The bacterial rods here is another anaerobic bacteria, Streptococcus, Microbacteria. Remember we mentioned Microbacterial tuberculosis phyli in our exam 1 and our lab 5. We did that. Throat culture. That's why we want to do a throat culture. How many bacteria here? Neisseria, Mycoplasma, Staphylococcus, Haemophilus, Corynebacteria. Stomach area. Very few bacteria, we mentioned low pH. Did I mention this before? Helicobacter pylori, it's HP. They can survive, cause stomach cancer. Because they could be hydrolyzed. Urea become ammonia and carbon dioxide. They are urease test positive. So, stomach area. Small intestinal, lactobacillus, candida albicans. Look at the fecal area. Large intestinal. So there is some research today. They can get human fecal sample, extract the DNA, running 16-8 RNA biotechnology to see the patterns of the geo-electrophoresis. Then they can group different bacteria into different groups, same as the PFG did. That's another topic, which is intestinal microorganisms. So just want to tell you one thing. Look at the picture. The normal bacteria in your body is so huge. Okay, blood cell. We want to mention a little bit. You know that. First of all, we need, why your blood is red always? You have a red blood cell. That's very simple. Erythrocyte. If you're a normal person, you have a cut. The blood is bleeding. Very soon it will be sealed. Is that right? It's stop bleeding by itself. Why? Because there's a platelet cell, which is coming from a megakaryocytes. This is the macrophage monocytes. What I just mentioned here, the macrophage. Remember, we talk about Salmonella typhi and the typhi marrow. I said she's hiding there for a longer time, and later on when she died, people find her body in almost 80s. They find there is a macrophage hiding the Salmonella typhi in her spleen area. That's why the macrophage is important, because they can entrap it there and they can just let it hiding there or holding there. Sometimes the lysozyme goes there, sometimes it doesn't really work very well. It depends. Now, do not forget about it. There is 3 important things here. So for granulocytes, neutrophil. Neutrophil is always important. If you have inflammation, it will be attracting. All of them will go to the inflammation area to start to do working. Then release histamine. Okay, then to relieve your inflammation symptoms. Eosinophils. Eosinophils, this guy. Usually what happens is anti-parasites. If you have a parasite in your body, let's say Toxoplasma, this guy gonna start to work. Benzophil. Benzophil is another one. Pay much attention to the antihistamine, which is anti-inflammation. So, in the other time, if you are going to have inflammation, let's say you have a lung inflammation sometimes, you go to see a doctor. The doctor will be running a screening test of your blood cell. If you're seeing your neutrophil is increased dramatically, which means you have inflammation. At the same time, they're going to look at your white blood cell, especially the macrophage. If you see the macrophage number is dramatically increased, which means the macrophage is working in your body to start to do the defense. So in the old time, they do not have those like a CT scan or those systems. They're testing your blood cell to see how many blood cells is there in the change. Now B cell and the T cell, that's a real immune coming from lymph nodes. We're going to mention this real quick. This is a slide talk about phagocytosis. So if you have a bacteria coming, the macrophage is going to engulf it, become a phagocyte, and then they release lysozyme. The lysozyme will be reacted, then finally hydrolyze it. This is the macrophage will be coming. The macrophage also could be coming with a complex of antibody and antigen. We're going to call it optimization. We're going to talk about later. Okay, these are the slides. Look at your immune system in your body. Tonsil area is a reservoir for bacteria. That's why a lot of you take it out. Thymus gland, lymph nodes, spleen, bone marrow area. Usually it started from the bone marrow area. Okay, so this is the slides. Here we want to talk about. Okay. For some of the reasons, there is a big picture in the textbook cannot be uploaded. So I will print it out and put on the eCampus. And I will bring next Tuesday, everybody attending lecture can have a copy. We just talk about how our natural acquired immune system developed in our body. And I think it's very important. So I want to talk all the time. Okay, we finished to talk about all these non-specific immune. We're going to move on to specific immune. Specific immune, you know, it's called cell mediated immune, which is generally T cell. Another one, we call it humoral immune, which is we also call it antibody mediated immune, which means they will generate a B cell. At the end of the day, will generate antibody. These are the two things we call it a specific immune system. Now, in your body, how they generate, it depends. Therefore, there are two lines, which is called a T cell line and the B cell line. So how they come out? We have a big picture here, then we talk about detail right here. First of all, there is a stem cell. The stem cell is right there. The stem cell, they could go bone marrow. And you know that some people have immune deficiency disease. If you cannot do any medical treatments, what you're going to do the last one is transplant a new bone marrow. That's the reason. Okay, let's say we draw a bone like this. The bone marrow right here on the top. The bone marrow could go to a spleen and also could go to lymph nodes. This goes to is we call it a B cell line. Now the stem cell could also go another direction, which is thymus gland. If they go to the thymus gland, they also could go spleen and lymph nodes. Then they will go to, we call it T cell line. Now, how the B cell line really going to work and the T cell line going to work, it depends the antigen. Okay, so here comes something else. Okay, by the way, this is called acquired immune development. Now, how are they going to work? Let's say I had so-called large complex antigen. This large complex antigen will go to your body. Now, your body